Mars is one of the most fascinating destinations in our solar system, but for now, it is the only planet exclusively inhabited by robots. In 2024, the only known activity on Mars is carried out by 3 rovers: Curiosity, Perseverance, and Tianwen-1. These robots are constantly exploring the Martian surface and conducting experiments, but this situation is expected to continue for quite some time. While the idea of a space colony on Mars is a highly discussed dream, the reality is that we are nowhere near achieving this vision, especially in the near future. The dreams of exploring and colonizing Mars are driven by several reasons. Many advocates of space exploration believe that humanity needs to establish a space colony to ensure our long-term survival. The idea is that if a catastrophic event were to occur on Earth, such as a devastating nuclear war or a collision with an asteroid, having a human base on Mars would ensure that human life could continue, preserving our species. This is what we might call the survival argument. Colonizing Mars, therefore, is seen as a matter of ensuring the continuity of humanity. On the other hand, there are those who view the exploration and colonization of Mars as an opportunity for prosperity. This group believes that the commercial and industrial exploitation of the solar system could bring immense wealth to Earth. The idea is that the industrialization of Mars and other celestial bodies could alleviate material problems on Earth, such as violence and conflicts between nations. This is the prosperity argument. Colonizing Mars and space could significantly improve the quality of life on Earth. However, today, in the first half of the 21st century, we are witnessing a new era in space exploration. An increasing number of private companies are taking a leading role in space exploration. Companies like Orbital, Northrop Grumman, and Sierra Space are developing their own space missions and gaining expertise in the field, which was previously dominated exclusively by governments. And of course, we cannot forget SpaceX, which also plays a crucial role in this scenario. The goals of space exploration now extend beyond national interests. For the first time, we have space exploration missions led by prominent figures like billionaire Jeff Bezos of Amazon and his space exploration company, Blue Origin. One of Blue Origin's explicit goals is to create a future where millions of people can travel and even work in space. This dream is largely driven by Bezos's personal interests and his vision for space exploration. Personally, I am a huge space exploration enthusiast. I am fascinated by the possibilities that arise when we imagine how humans might leave our planet and explore the vast cosmos. Therefore, I must admit that I also dream of the day when we will see humans inhabiting Mars. However, I need to be realistic, and for that reason I feel a bit of sadness in saying that Jeff Bezos's ambitions and those of other visionaries for a Martian future in the short term may be premature. The reality is that 21st century humanity is not ready to colonize Mars, neither in the short term nor the medium term. Trying to establish a colony on Mars now would likely lead to a series of serious problems and loss of life. There are 4 main challenges that make the colonization of Mars an extremely complex and, in fact, currently impossible endeavor. The first challenge is leaving Earth. To get to Mars, we need to overcome Earth's gravity, which requires a speed of approximately 25,000 miles per hour. The most efficient way known to achieve this speed is through rockets. Rockets use violent chemical reactions to expel gas in one direction and move in the opposite direction, following Newton's third law. They carry all the fuel needed for this propulsion. However, this approach is extremely inefficient. To send a ton of material into space, it is necessary to carry about 440 pounds of fuel. This increases the rocket's weight to 2.6 tons, and consequently more fuel is needed to carry that additional weight. This cycle leads to an even greater need for fuel, resulting in rockets that are very large and heavy just to transport a small amount of useful material. Ultimately, a rocket with 88 tons is needed to carry a single ton of payload into space. Moreover, since most of the rocket fuel is used to carry more fuel, space travel becomes extremely expensive. One potential solution to reduce rocket costs would be to establish a colony on the Moon. A semi-permanent base on the Moon with industrial capabilities could make Mars and solar system exploration much more cost-effective in the long run. The Moon is significantly further from Earth's center of gravity than the surface, which would make launching rockets from the Moon much cheaper. However, Moon colonization faces virtually the same technical challenges as Mars colonization, so it is not about to happen either. Another important factor to consider is the need for self-sufficient and redundant life support systems. On Mars, any failure in an essential system such as oxygen production or water filtration could be fatal. Life support systems need to be designed to operate autonomously and be able to quickly recover from failures to ensure the survival of the inhabitants. The second major challenge is the danger of space. Despite the eagerness of many enthusiasts to reach Mars in the coming decades, we need to consider that Mars is an average of more than 125 million miles from Earth. The best launch windows occur every 2 years, and the journey to Mars takes about 260 days with current technology. This time is comparable to the average time an astronaut spends on the International Space Station. Such a long journey is close to the limit of our knowledge about the effects of space on humans. Problems with this journey include muscle atrophy due to the lack of gravity. To minimize this loss, an intense exercise regime would be necessary. Additionally, the lack of gravity can affect vision, with astronauts developing eye problems after months in space. Reduced gravity can also cause neural degeneration, affecting fine motor control. On Earth, the magnetic field protects us from intense solar radiation, but in space, astronauts are exposed to higher levels of radiation, increasing the risk of chronic diseases during a mission to Mars. These problems do not necessarily mean immediate death or mission failure, but they can weaken the crew members. The combination of physiological problems with the unprecedented challenges of a mission to Mars could lead to a catastrophe. Mars is not exactly a safe place. Although the presence of gravity might help mitigate some effects, the truth is we do not know how reduced gravity will affect humans. Additionally, Mars does not have a magnetic field, which means we will need to find ways to protect astronauts from solar radiation on the surface. Another problem is that about 1% of Martian soil is composed of perchlorates, a toxic salt for humans. Direct and prolonged exposure to this substance can cause health issues. A base on Mars would need an effective solution to avoid perchlorate contamination, which also represents a challenge for plants used to produce food and oxygen. The third challenge is keeping humans alive. To do this, we need to ensure the availability of food and oxygen. Mars has water and oxygen in the water, and a well-equipped base could use these resources to produce oxygen and potable water. The base would also need to implement an efficient recycling system, which would include the reuse of breathed air and biological waste. Having living organisms on the base, such as plants, fungi, or food printing technologies, would help create a closed ecosystem capable of supporting life for extended periods. Attempts to create closed ecosystems on Earth, such as Biosphere 2, have shown controversial results. Biosphere 2 was an experiment that tried to create a closed ecosystem but faced several problems, including the inability to maintain adequate oxygen levels and the division of participants into conflicting groups. These psychological and operational challenges highlight the difficulty of creating a sustainable environment on Mars. Moreover, the logistics of sending supplies to Mars represents a significant challenge. Until we can develop more advanced and sustainable technologies, we will rely on regular resupply missions to provide the necessary resources for the survival and operation of a Martian colony. These missions will be complex and expensive, and any delay or failure could jeopardize the viability of the colony. Given the complexity of these challenges, it is clear that Mars colonization is far from being a reality. To move forward, we need to continue researching and developing technologies that will allow us to address these issues effectively. Research missions and the construction of a base on the Moon may be necessary steps before attempting to establish a colony on Mars. Our civilization on Earth needs to continue to thrive and ensure our security before embarking on such ambitious endeavors as Mars colonization. If you could be one of the first colonizers of Mars, what would your decision be? Share your opinion in the comments and join the discussion. Thank you very much for tuning in, and see you next time.